In this video, we're going to look at parent functions. So parent functions, we have a couple that we know and a couple that we're going to continue to talk about in class. So the first one I want to talk about is just a constant function or a horizontal line. So an example of this, if we have y equals 0, then we just end up with this horizontal line at 0, right? We know our slope-intercept form, and this is a function because it passes the vertical line test, y equals 0. So if there's any constant of y equals, we know that that's just what y equals. It's just a horizontal line. A parent linear function is just that, the linear function with the slope up 1 over 1. It has a positive slope and a y-intercept at 0. So we know that our slope, we refer to that usually as m, is 1, and our y-intercept, or the b value, is 0. Right? So we start at the origin 0, 0, and we have a slope from there. Now, from some of our parent functions, we can come up with different information that we know. So, for example, we have a vertical line. If a horizontal line is y equals, then a vertical line is x equals. Now, notice I did not call this a function, because it would not be a function. So an example of this, I could say x equals 2. And if x equals 2, then we just have a vertical line at 2, right? So we have looked at this using just a number line, and then it would be a point. But if we're looking at a coordinate plane, it would be the whole vertical line of x equals 2. And then you know about slope-intercept that you should remember. M is our slope, which we know is rise over run. I hope this is all very much a review, and B is your y-intercept. I'm not going to write out the whole word because you should know that by now. The next one is quadratic, and you spent a lot of time working on quadratic functions in Algebra 2. So our parent quadratic function, a reminder to us, if we plug in values, so negative 2 squared, remember you would do negative 2 squared, which would give you positive 4. Negative 1 squared is 1, 0 squared is 0, 1, and then 4. So this is our parent function, and then if we have 1, 2, 3, 4, if we plugged in 3, what would we get then? We should get 9, right? So we started to notice a pattern with that, and we'll talk more about the pattern later. So, and then this would continue on to infinity in this example. I know our example from yesterday, we restricted it, and we'll talk more about that also. So the next part, you're going to write down the 3 different forms and leave space. So after standard form, or if you write standard form next to this here, maybe leave 2 or 3 lines. And we're going to write down characteristics together as a class. But I want us to think about this overnight and try to figure out what are things that you remember or you know about the graph based on these forms. So we have standard form, we have vertex form, we have factored form. Write those down, and we will talk about those tomorrow. We will also write those down in class tomorrow. So leaving space here is important, and spending some time thinking about it, and I will see you then.